Example number 2. In this example, we see that our denominators are different. So we're going to subtract this using the concepts of dissimilar rational expressions. To do that, the first step is to find the LCD. To find the LCD, we take a look at the denominators and identify the factor or factors common to both of them. We see that m-1 is a factor that's common to both denominators. So we say that the LCD would contain the factor m-1. As always, we take the highest or the higher exponent between m-1 quantity squared and the second denominator, which is understood to be m-1 to the first power. The higher exponent is 2. So in our LCD, it would then contain the factor of m-1 quantity squared. There is no other factor common to both of them, so we move on to the next step in identifying the LCD, which is to get the not common factor or factors. Between these denominators, there is no factor that is not common to both of them. So our LCD is going to be m-1 quantity squared. After getting the LCD, the next step is to change to similar rational expressions. We do this by multiplying each rational expression by an expression equivalent to 1 so that we will have an equivalent rational expression which makes use of the LCD. Considering the first rational expression of 6m minus 2 all over m minus 1 quantity squared, notice that the denominator of this rational expression already uses the LCD. So we don't need to multiply this by an expression equal to 1. Moving on to the second rational expression, which is 5 over m minus 1, we multiply this by m minus 1 so that we will end up with an equivalent rational expression which makes use of the denominator of m minus 1 quantity squared, which is exactly what our LCD is. So if we're going to multiply the denominator by m minus 1, we also multiply the numerator by m minus 1. And we would end up with a numerator of 5 times m minus 1. Copying the first expression, we then have 6m minus 2 all over m minus 1 quantity squared minus 5 times m minus 1 all over m minus 1 squared. We can simplify the second numerator by applying the distributive property. This will then give us with 6m minus 2 all over m minus 1 quantity squared minus 5 times m is 5m and 5 times negative 1 is negative 5 all over m minus 1 quantity squared. You would see here in our latest expression that we are now going to work with expressions that have the same denominator. Since the denominators are now the same, we would now move on with how to operate with similar rational expressions. And the way we do that, we operate with the numerators and copy the common denominator. So, working on the numerators, this would give us 6m minus 2 minus the entire second numerator of 5m minus 5. Take note how this was written. It's going to be written as minus parenthesis of 5m minus 5 to mean that we are subtracting the entire second numerator. All over, copy the common denominator of m minus 1 squared. It is important to note that in our numerator, we would have a parenthesis that is preceded by a minus sign. When we simplify this now further, this becomes 6m minus 2, and removing the parenthesis, it becomes minus 5m plus 5 all over m minus 1 quantity squared. Combining like terms, 6m and negative 5m would give us m, and combining negative 2 and positive 5, this would give us positive 3 all over m minus 1 quantity squared. We cannot further simplify this because there's no other factor that's common to both numerator and denominator which we can cancel out. All that is left to do is to simplify or to finalize things by writing your restriction. To write your restriction, take a look at your denominators. We made use of the denominator of m minus 1. So we don't want m minus 1 to be equal to 0 because we don't want to end up with an undefined fraction. For m minus 1 not to be equal to 0, then the restriction is m should not be equal to positive 1. Therefore, this is going to be our final answer. This time, work on exercise 7.06 in Schoology. Take note that the items from this exercise were taken from your textbook.